All right, what have we learned so far? SSH uses both symmetric and asymmetric encryption. Since asymmetric encryption is more time-consuming, most of the SSH connections use symmetric encryption, as we've discussed. The idea behind is that asymmetric encryption is used only to share a secret key, and then finally using that key, that is symmetric encryption, for further communication so it's fast. Now, once a secure symmetric communication has been established, the server uses the client's public key and generate a challenge and transmit it to the client for authentication. If the client can successfully decrypt the message, well, it means that it holds the private key required for a connection. Then the SSH session finally begins. So we finally have this secure tunnel, everything's happy, and we can communicate in a secure way. One problem though. Someone can sit in the middle and pretend to be the other and tamper or modify the message. If they somehow convince the client that they're the host and the host that they're the client, they can just have this key exchange between one another and the information can flow through that middleman. Now, to solve one of these problems, we'll talk about something called hashing. And hashing is another form of cryptography used in secure shell connections. Now, in my other course, The Complete Web Developer, we use something called bcrypt to hash passwords. So you may remember that. Now, one-way hash functions differ from the above two forms of encryption, the symmetrical and an asymmetric, in that they're never meant to decrypt anything. They simply generate a unique value of a fixed length for each input that it gets. And they're one way because if I hash hello, it's going to run through a function that spits out gibberish really, really fast, with the trick being that we have no idea how to get back to the hello text. So if going through a hash, if somebody looks at this, it's pretty much impossible for anybody to go back and figure out what this means. So how is that useful? Well, as we mentioned before, SSH is able to transmit messages securely, but if a third party is able to dupe the client and the host, well, they can tamper with the messages. Maybe they could change the messages for nefarious reasons. Luckily for us, using the third technique, hashes, we're able to verify the authentication of the messages. So the bad person can modify our messages. This is done using something called HMACs, or hash-based message authentication codes. I know it's a mouthful. These names are getting really, really confusing. But the gist of it is this. Using a hash function, each message that is transmitted must contain something called MAC. And this MAC is a hash generated from the symmetric key, the packet sequence number, and the message contents that we're sending. So let's say this client is trying to send the password with the host and they've already established a symmetric key for secure communication. Well, using the packet sequence number, the key, and then whatever text I'm sending, in this case, let's just say we're sending the password, I combine this as an input into a hash function, and this function is going to spit out some piece of string that means absolutely nothing. And now this is sent to the host. But this means nothing, right? So how can the host check that the message hasn't been tampered with? Well, what they can do now is, because they have the same information, they can use their own symmetric key, which is the same as the client's. They can use the packet sequence number, again, which they both know. And then because this message was sent through SSH, they also have that message that was sent. So now they run it through the same hash function again, and once it calculates it, it's going to see, does what I just generated match what the client's hash was? And if it does match, well, that means that this message was not tampered with. Because at any point, if the password, even one letter, even a capitalization was changed, this hash will be completely different. And that is one characteristic of hash functions. Change any single thing, no matter how similar the inputs may be, it's going to spit out a completely different number. Now, learning everything we have up until this point, we should understand what's going on when we type in SSH at IP address. Or do we? You see, up until now, I may have lied to you a little bit. Because everything that we've talked about, if I go to my terminal right now and we only implemented this, well, I would SSH into that DigitalOcean server, press enter, and I get a password requirement. But that didn't happen, did it, when I showed you in previous videos? I just immediately logged on and I was able to do anything that I wanted. And like I said, I cheated a little bit here. And I'll show you why that was and why we need to finally enter a password in the next video. I know, a little bit of a cliffhanger. I'll see you in the next video. Bye-bye.